Bismillahirrahmanirrahim. Welcome to the 11th lecture of Statistics and Probability Theory. In previous lecture, we have studied binomial distribution. Binomial distribution is extension of the binary trial. We have two parameters in binomial distribution, which are n and of success. Binomial distribution has certain properties. Property number one was each outcome is classified into two categories, success and failure. And second one was that experiment is repeated a fixed number of times. Number third was each successive trial is independent, and the fourth one was that probability of success remains constant from trial to trial. PDF or probability mass function of binomial distribution was n c x e raised to power x and q raised to power n minus x, where x is equal to 0, 1 up to n. So this is the probability mass function of binomial distribution, and mean of binomial distribution is n into p, whereas variance is equal to n p q. Topic of today's lecture is multinomial experiment and multinomial distribution. The binomial experiment becomes a multinomial experiment if we let each trial to have more than two possible outcomes. As you know that binomial distribution have two possible outcomes, which we classified as success and failure. Whenever we have more than two possible outcomes in the experiment and the remaining properties remains the same, that the probability of success remains the constant, experiment is repeated a fixed number of times, each successive trial is independent from the other trial, so this is called the multinomial experiment. For example, the classification of manufactured product as being light, heavy, or acceptable. The recording of accidents at a certain intersection according to the day of the week. The drawing of card from a deck with replacement if the four suits are the outcomes of the interest. So, in general, if a given trial can result in any one of k possible outcomes, let's suppose we have k possible outcomes E1, E2 till Ek, and their probabilities are P1, P2 and Pk, then the multinomial distribution will give the probability that E1 occurs x1 times, E2 occurs x2 times, and Ek occur xk times. As you remember from the binomial distribution, we have one random variable x which is associated with the probability of success. We have two possible outcomes here, success and failure, and we are associating our random variable with the probability of success. But in the case of multinomial, we have k possible outcomes and each possibility has the probability of occurrence P1, P2 till Pk. So each category will have its random variable. Let's say E1 has x1, E2 is associated with x2, and up to so on till xk times in n independent trials, as our trials are independent because multinomial is the extension of the binomial distribution. So x1 is the number of times E1 occurs, x2 is the number of times E2 occurs. So when we sum up all these, it will be equal to small n, which is number of trials. And as we know that total probability is always 1. In the case of binomial, we have two possible outcomes P and Q, and we know that P plus Q will be equal to 1. So in the case of multinomial, we have P1, P2 till Pk. When we sum up, then it will give us the probability 1. Since the result of each trial must be one of the kth possible outcomes. Probability mass function of multinomial distribution. So according to the scenario defined, the mass function of the multinomial distribution is f of x1, x2, xk, as we have k possible outcomes. So each one is associated with each possible outcome, and P1, P2, Pk is the probability. X1 is associated with P1, X2 is associated with P2, and up to so on, Xk is associated with Pk, and N is the total number of trials. This is the case of different categories. In the case of binomial, we were writing NCX as we have two possible outcomes in the binomial distribution. So we are taking here only one possibility, which was success X here. But in the case of multinomial, we have k possible outcomes. So we are considering each category here, x1, x2, xk, and p1 raised to power x1, p2 raised to power x2, up to so on pk raised to power xk, where sum of xi is equal to n and sum of pi is equal to 1. This is the same as we have defined here. This thing is written like this. Now we will elaborate the multinomial distribution with the help of the example. The complexity of arrivals and departures of planes at an airport is such that computer simulation is often used to model the ideal conditions. For a certain airport with 3 runways, it is known that the ideal setting the following are the probabilities that the individual runways are accessed by a randomly arriving commercial jet. So we have 3 runways, runway number 1, runway number 2, and runway number 3, and the arrival possibilities of a commercial jet in runway number 1 is 2 by 9, in runway number 2 is 1 by 6, and in runway number 3 is 11 by 18. We are associating the probability P1 with runway number 1, P2 with runway number 2, and P3 with runway number 3. As we have 3 categories, runway 1, runway 2, and runway 3. So we have P1, P2, and P3. What is the probability that 6 randomly arriving airplanes are distributed in the following fashion? We have 6 randomly arriving airplanes. At runway number 1, we have 2 airplanes. At runway number 2, we have 1 airplane. And at runway number 3, we have 3 airplanes. So, first we have to see that either the properties of the multinomial distribution are fulfilling here or not. The first property is we have k possible outcomes. We have k possible outcomes, or you can say we have k categories. So here you can see that we have 3 runways, runway number 1, runway number 2 and runway number 3. So here that airplane can arrive at runway 1, runway 2 and runway 3. So it means we have 3 categories. So first property is fulfilling here. Second number is experiment is performed n times or fixed number of times. So here we have total 6 randomly arriving airplanes. So second property is also fulfilling here. And the third property is that each successive trial is independent. So arriving the airplane is the trial, as we are saying that n is equal to 6. There are 6 airplanes. So each plane is the trial. Arrival of each airplane is the trial. So each airplane is independent from the other airplane. So third property is also fulfilling here. And property number 4 is that probability of success remains the same. Here we have 3 categories and all of them are considered as success, that the we are saying that we are finding out the probability of that 6 randomly arriving airplanes are distributed at the runways. So the arrival probability at the runway number 1 is 2 by 9, and not probability of not arriving is 1 minus P1, which is 1 minus 2 by 9, and it would be 7 by 9. Similarly, 1 minus P2, which is equal to 1 minus 1 by 6, which is 5 by 6. And 1 minus P3 is obviously 1 minus 11 by 18. So you can find out the probability of not arriving the airplane jet like this, and so the probability of success is constant, or you can say it remains constant from the trial to trial. That is, if any of the 6 airplanes are coming to the runway 1, the probability of its arrival will be 2 by 9 for any of these 6 randomly selected airplanes. And if they are coming at runway 2, then the probability would be 1 by 6. And if they are coming at runway 3, then the probability will be 11 by 18. So each of the airplane will contain the same probability according to the runways. Now, what we have seen from the example, that experiment is performing n times, n is equal to 6, x1 is associated with the runway number 1, x2 is associated with the runway number 2, and x3 is associated with the runway number 3. As you all know that P1 is equal to 2 by 9, P2 is equal to 1 by 6, P3 is equal to 11 by 18. As you can see there, runway 1, at runway 1, 2 airplanes are arriving, so it is using 2 times. At runway number 2, 1 airplane is arriving, so it is using 1 time. At runway 3, 3 airplanes are arriving, So it is using 3 times. So according to the probability mass function of multinomial distribution, it would be f of x1, x2, x3, and p1, p2. I am writing in the same manner as it is written in the above slide or previous slide, p3 and n, which is equal to n x1, x2, and x3. This is the combination for different categories. P1 raised to power x1, P2 raised to power x2, and these three are multiplying with each other. P2 raised to power x3. So as you can see from the previous slide that x1 is equal to 2, x2 is 1, and x3 is 3. P1 is 2 by 9, P2 is 1 by 6, P3 is 11 by 18, and n is equal to 6. Here we have to substitute n, so it is 6, 2, 1, 3. Accordingly, this x1, x2, x3, p1 is 2 by 9, again raised to power x1, and x1 is 2. Here raised to power x2, x2 is 1, p3 raised to power x3, p3 is 11 by 18, and x3 is 3. So by solving this, how you will open this x, c, 2, 1, and 3? It will open like this: x factorial over 2 factorial, 1 factorial, and 3 factorial. It will open like this. So by solving all this, you will get 0.1127. This is the probability that 6 randomly arriving airplanes distributing in this fashion. So you can find out the probability of more than 2 possible outcomes by fulfilling the all other properties. As you know, in the binomial, the property change here is that now you have more than 2 possible outcomes. Like you have more than 2 categories or more than 2 categories for the success.